bit to this slide. Last week we didn't finish this, but we talked a little bit about it. And from this week, I will review some key points for this issue. Alright, as you see on either the slide or on the blackboard that we have the demand and supply functions. The quantity demanded is described as a demand function of P, the price. And here I denote it as a negative relationship. It's an inverse relationship. So satisfying what? The law of demand. Alright? The law of demand means the relationship between the quantity and the price is negative. It's a downward sloping curve. Alright? And when the price changes, the quantity will move along the curve. When the price goes up, the quantity will decrease, right? So the relationship between QD and P is captured by this curve. So the points on the curve will move along the curve. Get it? So you got a high price, you got a lower quantity demanded. And the supply curve. There are two factors affecting the supply. So one is price as well. And I denote it as a positive, there is a positive sign here because of the law of supply. So the price and the quantity supplied is a positive relationship. And without the change of A, when P changes, the quantity or the points on the slide will move along the supply. Okay? So you have a higher, when the price goes up, the quantity supply will go up as well. So the relationship between price and quantity is captured by a point moving along the curve. Get it? And here, A as is a supply shifter, So would you please highlight this term? Is a supply shifter. So far, we have not specified the relationship between A and QS, whether it be positive or negative. But when A changes, the curve, the whole supply curve, will shift either outward or inward. If the relationship between A and QS is positive, then when A increases, the supply curve will shift outward. If it is negative, then the supply curve will shift inward. Is that clear? Okay, once again. So the price, when the price changes, the quantity demanded will move along the demand curve. When the price changes, the quantity supply will move along the supply curve. But the supply shifter A, when it changes, the whole supply curve either move outward or inward, to the right or to the left. Okay? It depends on their relationship, be positive or negative. If it is positive, then it shifts to the right. Okay? And the reason why it shifts to the right is because when A changes without any change in P, which means Q, partial QS, partial A, when this is positive. So let the price remain the same, and the quantity will move to the right, right? Because the quantity supplied affected by A is positive. So an increase in A will make the quantity supply move to the right. So another price hold constant, move to the right. Move to the right. Okay? Without any change in P. Without changing P. So when A increases, holding P constant. So P is hold constant, then the QS will move to the right because we assume it is positive. Is that clear? All right. And at equilibrium, this is the condition for equilibrium. QD, quantity demanded, equals quantity supplied. So the intercept, the point that the demand curve cuts the supply curve, the intercept is the equilibrium point, right? So it corresponds to the equilibrium price and equilibrium quantity. So when we reach a equilibrium, then quantity demanded must meet quantity supplied. If the price is not at equilibrium price, if the price is higher than the equilibrium price, what would happen? When the price goes up, what would happen? The quantity supply exceeds the quantity demand, right? So it's an oversupply. It's a surplus, okay? So when the price is below the equilibrium price, the quantity demanded exceeds the quantity supplied. It's a shortage. So only at this equilibrium price, the quantity demanded equals the quantity supplied. And by this condition, we may have an implicit function that the price is actually a function of the supply shifter A. Therefore, this condition can be rewritten as demand of P, and P is a function of A, equals the quantity supplied is a function of P, which is a function of A, and A. Okay? So we'd like to know, how about an increase in A? How about an increase in A by 1 unit? When A goes up by 1 unit, A will affect the price, and the price will affect the quantity demanded. Okay? So this is an indirect relationship. And here as well, A affects P. P affects quantity supply. But A may affect quantity supply directly. So there are two channels in the supply curve, one direct and the other, one indirect and the other direct. Now, we may remember that this equal sign holds only at equilibrium. And also, because of the equilibrium condition, the price can be described as a function of A, only at equilibrium, okay? And we total differentiate the whole equation, the left-hand side and the right-hand side. Differentiate the whole equation by A. And we have the result here. And let's review the equation. A affects P using D. The reason why it is D because there is the single argument A. A is the single argument or factor affecting P. Okay? And P affects D. Also, as well, using D because quantity dependent has only one argument or one variable, one independent variable in the demand function. But here you will see A affects P, but P affects the quantity supply is a partial differentiation. The reason why we use partial differentiation is because there are two variables in the supply curve, in the supply function. So we like to know how about P changes, how about the quantity is affected by the change in P, holding A constant. So we deal with one variable at a time. Okay? So this is the reason why we use partial. And also, A affects quantity supply directly. Okay? So it's also a partial differentiation. And we rearrange the equation, we have this outcome. So last week we stop here. Okay. The term on the left-hand side is dPdA. So we have to interpret what dPdA is. So we'd like to know how P changes. What is the size of the change in P caused by a change in A by 1 unit? This is what we want to know. Alright? So we want to use the comparative static analysis to analyze this issue. So in case number 1, since we assume that partial QS, partial A is positive, which means when A changes by 1 unit, the supply curve will shift to the right, as this on the blackboard. So the equilibrium point will move from here to here, right? Is that right? So we like to know before and after the change in A. Before and after the change in A. What is the size and what is the direction? The size and the direction, or the direction and the size of the change in P star. That is what we want to know. Okay? Is everyone happy so far? So we want to know what is the change in A by 1 unit in A makes the equilibrium price change. How does a change in A make the equilibrium price change? the direction, and the size, the magnitude. Alright, this is what we want to know. And on the right hand side we have partial S, partial A on the top, and partial D, partial price, partial, DP, DP. And partial S, partial P. Now, what is this? How can we interpret this term? This term is actually the effect of the change, the size of the change in QS, Q supply, quantity supplied, by a unit change in A. Okay? So A goes up by 1 unit, and how many units of quantity supply goes up or goes down? We'd like to know the size, the magnitude. So last week we have talked about this. Now, have a look at this. I'll make it larger than that diagram. Initially, the equilibrium price is at here, P star. Initially, quantity demanded and quantity supplied meet each other, right? Now, because there is a change in A by 1 unit, next the quantity supply move to the right because we assume the relationship is positive, so it moves to the right. This is the S prime. Now, notice that here we use a partial differentiation, which means although S is affected by P and A, but now we want to study the effect by A, so we hold P what? Unchanged or constant. Alright? So when P is held constant, and this part will be the effect caused by the change in A, right? So it's a quantity, right? This is a quantity, the initial quantity, and a new quantity. So the size of change will be this much, okay? And this is partial S, partial A. Is that clear? Is that clear? Okay? Now we want to know, what is this? Before I interpret this term to you, I'd like to give you an example. Okay, think about this. Assume that you owe me some money, say $10,000. You owe me $10,000, and you like to return the money to me as soon as possible. So you decide to do 2 things. One is to cut your monthly consumption, say by by $300. So let me give you an example. You owe me $10,000, and you decide to cut your consumption. You want to cut your consumption for every month. For every month by, say, $300. And you work harder to earn your income more for every month by say $700. Okay, so for each month you can return me how much money? You cut your consumption and also you earn more. So you can return me by $1,000 each month, right? Okay? Now you owe me $10,000 and you may return me $1,000 per month. How many months? After how many months you can return me all the money? 10, right? Is that clear? So you owe me $10,000 and you cut your consumption, you earn more, so you can return me $1,000 per month. So totally, in 10 months, you can return all the money to me, right? Is that clear? Okay? All right. Now, when the price is held constant and there is a change in A, makes the supply curve shift to the right, and there is a gap. Now the new supply curve, the initial demand curve, we have a new quantity supplied and a new quantity demanded, right? And there is a gap. This gap, we call it excess supplied, oversupply. Okay? It's a surplus. It's a surplus. Okay? It's a surplus. So without any change in P, we now are facing a gap there. And you know the market power will make the price trying very hard to goes down. So that when the price goes down, we may reach a new equilibrium. Is that right? Okay? Now, suppose this is 1 unit in P. The size here is 1 unit in the price, okay? So for the change of 1 unit in P, the quantity demanded will what? Increases. Well, the quantity demanded goes up, will increase. And the quantity supplied will what? Decrease, right? Just like you cut your consumption and you earn more, something like that. Okay? So, since you owe me this much, and by every price, you may make the quantity demanded increase and make the quantity supply decrease. Okay? So, this part, when the price change is 1 unit, then what is the size by this? It is that clear? This is the demand curve, right? And how we interpret this term? 1 unit change in P, how many unit in quantity demanded, right? So now, when the P goes down by 1 unit, and this size, which means the change in quantity demanded, would correspond to this term. Is that right? Okay. So this term, actually we give it an absolute value. So this would be the size of this. And what about the other one? What about this? This is the supply curve, and facing a 1 unit decrease in P, the quantity supply will decrease by QS, and this is exactly QS P, or using the notation partial S partial P. So this would be partial S partial P, and this is this. Okay? Absolute value here. Now, so you owe me $10,000 and you cut your consumption, you increase your earnings, and cut your consumption by $300, increasing your salary by $700 per month. So totally, you have 1,000 to return, so it's 10 months. It's the same thing here. Now you owe me this much. You owe me this much, and this must be positive, right? Because we assume it is positive. So this is positive, and for each unit decrease in P, for each unit decrease in P, you may return this and this, right? You increase the quantity demanded and you cut the quantity supplied. So totally, partial S, partial A, totally this is the size you may return by each unit in P, okay? And this is the gap. So how many units changes in P can make the gap disappear, can erase the P perfectly? How many units in P? This unit in P, right? Is that clear, the concept? Do you get the idea? Yes or no? Give me an answer. You respond me, please. Respond to me, please. Yes or no? Is that clear? If not, just tell me which point you just didn't get it. I think this is when I teach microeconomics, this can be the most clear way, or the clearest way that I have ever thought about to explain. Okay, this is the gap, and by each unit changes in P, you increase the quantity demanded and decrease the quantity supplied. So this is by 1 unit change in P. This is the total gap. Okay, so the ratio is actually how many units in P to change. You may erase the gap perfectly. Okay, so this is exactly this. And now let's check. This term, is it positive or negative? Is this term positive?